Let's start with the basics. Understanding the fundamentals is crucial before diving into more complex topics. In maths, a function is like a machine. Imagine a machine where you put something in, and it processes that input to give you an output. You put something in, and it spits something out. This process is systematic and follows a specific rule or set of instructions. We call what you put in the input. The input is the starting point, the raw material that the function will work on. What comes out is the output. The output is the result after the function has processed the input. Importantly, for each input, a function only gives you one output. This means that a function is consistent and predictable. The domain is all the possible inputs a function can handle. It's like a list of all the ingredients you can use in a recipe. The range is all the possible outputs. These are the results you can get after processing the inputs through the function. Think of it like this. The domain is the ingredients you can put in a cake recipe. You have a variety of ingredients to choose from. The range is all the different cakes you can bake. Depending on the ingredients and the recipe, you can create a variety of cakes, each unique in its own way. Functions are fundamental in mathematics because they help us understand relationships between different quantities. They allow us to model real-world situations and solve problems efficiently. For example, in physics, functions can describe how the position of an object changes over time. In economics, they can model how supply and demand affect prices. There are different types of functions, such as linear, quadratic, and exponential functions. Each type has its own characteristics and applications. Linear functions have a constant rate of change and are represented by straight lines. Quadratic functions, on the other hand, have a variable rate of change and are represented by parabolas. Exponential functions grow or decay at a constant percentage rate. They are often used to model population growth, radioactive decay, and interest calculations. Understanding the basics of functions is essential for progressing in mathematics. It provides a foundation for more advanced topics and helps develop problem-solving skills. So remember, a function is like a machine. You put in an input, and you get an output. The domain is all the possible inputs, and the range is all the possible outputs. With this understanding, you're ready to explore more complex mathematical concepts. Keep practicing, and soon you'll master the art of functions. Happy learning! Now imagine a special type of function. This function is very picky. It only gives you a unique output for every unique input. This means that no two inputs will ever give you the same output. This special function is called a one-to-one function. For example, the function doubling a number is 1 to 1. If you double 2, you get 4. If you double 3, you get 6. You never get the same output from two different inputs. On the other hand, think about squaring a number. Both 2 and -2 give you 4 when squared. This function is not 1 to 1. Now let's delve deeper into what makes a function 1 to 1. Imagine you have a magical machine that takes an input, processes it, and gives you an output. For a function to be 1 to 1, this machine must be designed in such a way that each unique input produces a unique output. No two different inputs can ever result in the same output. This is a crucial characteristic of one-to-one functions. Consider the function fx equals sign 2x. If you input 1, the output is 2. If you input 2, the output is 4. If you input 3, the output is 6. Notice how each input gives a different output. This is what makes the function x equals sine 2x a one-to-one function. There is a clear, distinct relationship between each input and its corresponding output. Now let's contrast this with a function that is not one-to-one. Take the function g of x equals sine x squared. If you input 2, the output is 4. But if you input -2, the output is also 4. Here, two different inputs, 2 and -2, give the same output, 4. This overlap means that the function gx equals sine x squared is not one-to-one. One-to-one functions are important in mathematics because they have unique properties that make them useful in various applications. For instance, they are invertible, meaning you can reverse the process and find the original input from the output. This is not possible with functions that are not one-to-one. In summary, a one-to-one function is a special type of function where each unique input produces a unique output. This means that no two different inputs can result in the same output. Understanding this concept is fundamental in mathematics and helps in solving various problems and understanding more complex functions. So the next time you come across a function, try to determine if it is one-to-one. Look for that unique relationship between inputs and outputs. This will not only help you understand the function better, but also enhance your overall mathematical skills. One-to-one functions are everywhere in our daily lives. Think about your national insurance number. Each person has a unique number. This is a one-to-one relationship. Another example is your passport. Each passport has a unique number, and each number is assigned to only one person. Again, this is a one-to-one function in action. These real-world examples show how one-to-one functions help us organize and identify things. There's a neat trick to see if a function is one-to-one just by looking at its graph. It's called the horizontal line test. Imagine drawing horizontal lines across the graph of your function. If any line touches the graph more than once, the function is not one-to-one. This means two different inputs give the same output. If every horizontal line only ever touches the graph once, congrats! You've got yourself a one-to-one function. Section 5. Algebraically testing for one-to-one functions. In this section, we will delve into the algebraic methods used to determine if a function is one-to-one. This is a crucial concept in mathematics, especially in fields like calculus and linear algebra. We can also check if a function is one-to-one using algebra. This method involves a bit of logical reasoning and algebraic manipulation, but it is a powerful tool for understanding the behavior of functions. Let's say you have a function f of x. This function could be anything from a simple linear function to a more complex polynomial or even a trigonometric function. Assume f of a equals f of b, meaning two inputs a and b give the same output. This is the starting point for our test. If two different inputs produce the same output, we need to investigate further. Now try to solve this equation. This involves isolating the variables and simplifying the equation as much as possible. The goal is to see if we can prove that a must equal b. If you can only solve it when a equals b, then the function is one-to-one. This means that each input produces a unique output, and no two different inputs will ever produce the same output. This confirms that the same output only comes from the same input. In other words, the function passes the one-to-one test. If you find solutions where a and b are different, then the function is not one-to-one. This means that there are at least two different inputs that produce the same output, which fails the one-to-one test. Another way to visualize this concept is by using a graph. If a function is one-to-one, its graph will pass the horizontal line test. This means that no horizontal line will intersect the graph at more than one point. The horizontal line test is a quick visual check, but the algebraic method we discussed is more rigorous and can be applied to a wider range of functions. Practice is key to mastering this concept. Work through various examples and problems to get a solid understanding of how to test for one-to-one functions algebraically. Remember, understanding whether a function is one-to-one is fundamental in many areas of mathematics. It helps in solving equations, understanding function behavior, and even in real-world applications like cryptography and data analysis. So keep practicing and exploring different functions. The more you work with these concepts, the more intuitive they will become. Happy learning. Section 6. Why are one-to-one functions important? One-to-one functions are important because they have a special relationship with something called inverse functions. An inverse function is like reversing our function machine. It takes the output and tells you the original input. Only one-to-one functions have inverses that are also functions. This is because in a one-to-one function, each output corresponds to only one unique input. Section 7. The inverse function, a special relationship. Imagine you put the number 3 into the doubling function. You get 6 as the output. Now, with the inverse function, you put 6 in and it tells you the original input was 3. This undoing ability of the inverse function is incredibly useful in many areas of maths. Section 8. Applications of one-to-one functions. One-to-one functions and their inverses pop up everywhere in our daily lives. In cryptography, one-to-one functions help create secure and reliable codes. In computer science, they are essential for data compression and efficient retrieval. Even in economics, one-to-one Functions model things like supply and demand effectively. Understanding these functions unlocks a deeper understanding of how the world works around us. Section 9. Common mistakes with one-to-one functions. One common mistake is forgetting to check the entire domain of a function. Just because a function looks one-to-one in a small section doesn't mean it is for all possible inputs. Another mistake is confusing a one-to-one function with a function that just has a unique output for one specific input. Remember, for a function to be one-to-one, every single input must have a unique output. Section 10. Wrapping up one-to-one functions in a nutshell. So, there you have it. One-to-one functions are like special functions that pair each unique input with a unique output. They can be identified by the horizontal line test or by using algebra. Their inverses are like magical undo buttons, making them incredibly useful in various fields. From cryptography to economics, understanding one-to-one functions opens a door to a deeper understanding of mathematical relationships.